Hi, welcome to my channel. Today we can discuss simplex method containing less than or equal to constraints only.
Hi all, welcome back. Today we are going to discuss a topic in simplex algorithm. Here we are doing simplex algorithm less than or equal to constraints questions. We are going to discuss simplex algorithm with less than or equal to constraints. If any of the constraint contain greater than or equal to inequality, we need to go for another method which is called bigger method. Here only less than or equal to inequality constraints is we are looking. Okay. So we are going to the problem. This is a question. Solve the LPP using simplex algorithm. Maximize Z is equal to 30x1 plus 20x2 subject to 3x1 plus x2 less than or equal to 1500, x1 plus x2 less than or equal to 1000 and x1 comma x2 greater than or equal to 0. This is non-negativity constraint. It is not considered other constraints, that is 3x1 plus x2 less than or equal to 1500, x1 plus x2 less than or equal to 1000. These should be all these such type of constraints all should be less than or equal to. In formulation we does not consider the non-negativity constraint. It does not consider only these constraints here we are looking. Check whether these are less than or equal to constraints. You know the question is maximize Z. So every time the objective function, this is known as the objective function, and these are the constraints, and this is the non-negative constraint. Okay. So the objective function, every time the objective function should be of maximizing. Every time the objective function should be of maximizing. Otherwise, if the question is of a minimizing, we need to convert it into maximizing by simply multiplying the entire objective function with a negative one. Okay. So if it was minimize Z equal to 30x1 plus 20x2, then we will convert the minimization function to maximization by multiplying with a negative. So minimize Z become maximize Z. This 30x1 plus 20x2 become minus 30x1 minus 20x2. I just assert this time. If a question comes like that, we can discuss in the further questions. Okay, here it is clearly given maximizing. So first we need to convert the non-negativity constraints or the inequalities. These are the inequalities. These inequalities into a equation. Since this is less than or equal to constraint, since 3x1 plus x2 less than 1500, which means this left side is lacking something which is less than 1500. In order to equate it into 1500, we need to add something to the left side. Such type of variables is known as slack variables. Slack variables always add to the left hand side of the constraints. Okay. So less than means this side is lacking something in order to equate it with 1500. So I am introducing a new variable S1 in the first constraint. Similarly S2 in the second constraint in order to make this as equations. So first step, introducing slack variables. Slack variables means the variables that are adding to the left hand side of less than or equal to constraint in order to make it as equations. Introducing slack variables S1. In first equation we introduce S1. In the second equation we introduce S2. Introducing slack variables S1 and S2. Therefore, if we are introducing something to the constraint, it should be included in the objective function also. Therefore, our objective function become maximize z equal to 30x1 plus 20x2. The coefficient of slack variables in the objective function is always 0. So, objective function does not change. Plus 0s1 plus 0s2. Subject to, make it as equation 3x1 plus x2 plus s1 plus 0s2, which means there is no, in the first constraint there is no term containing s2, but in order to generalize it I am introducing 0s2 also. Okay, 0s2 is equal to 1500. The second constraint x1 plus x2, here there is no term of s1, so plus 0 s1 plus here we are introducing slack variable 2, that is s2, which is equal to 1000. Then our non-negativity constraint x1 comma x2 comma s1 comma s2 greater than or equal to 0. In the solution, if the solution we get a solution that is a negative number, which means it does not satisfy this constraint. So always our answer should be positive. Okay. So now we are going to the simplex table 1. Simplex table 1. So we are going to write the simplex table. This is the table heads, this is the basis. So we are writing the basic variable in this column. Then what are the variables? x1, s2, s1, s2. This is a constant value. For that I am writing the letter B. Okay. So every time the basis means it should have a unit vector in the equation. Look at the coefficients of x1, 3, 1. That is not a unit vector. x2, 1, 1. That is not a unit vector. 1, 0, 0, 1. 1, 0, 0, 1. These are the unit vector, which means the coefficient of that element having unit value 1 to that row, all other rows having 0. Look at here, 1, 0. In this row, S1 coefficient is 1. In the second row, S1 coefficient is 0. Similarly, look at the coefficients of S2. In the second row, the coefficient of S1 is 1. Other row having the coefficient 0. So, in the first table, always slack variable will be the basis variable. So, I am writing the basis variable as S1, S2. Then I am writing the coefficients of this equation in this table. The first equation, coefficient of x1 is 3, x2 1, s1 1, s2 0, b is 1500. The second equation, 1, 1, 0, 1000. Okay. Then here I am writing the cost of basic variable. Basic variables are S1 and S2. Its cost, it can be obtained from our objective function. What is the coefficient of S1 and S2 in the objective function? 0, 0. So the cost of base is 0. Similarly, I am writing the Cj values here. Cj values are the cost of this column variables. Okay, B doesn't having any cost, this variable. It is also we will get from the objective function. X1 30, x2 20, s1 0, s2 0. This is the initial table we are writing. Now we need to find out a set of values known as Zj value. Zj value. Zj value. Zj is obtained by multiplying this column vector with this column. That is 0 into 3 plus 0 into 1. That is 3 plus 0 into 3, 0. 0 into 1, 0. So 0 plus 0, 0. Next column 0 into 1 plus 0 into 1. 0 plus 0, 0. Next 0 into 1 plus 0 into 0, 0. 0 into 0 plus 0 into 1, 0. Also write the value of Zj for column B. 0 into 1500 plus 0 into 1000, the value is 0. Now I need to find a set of another value capital Cj equal to Zj minus small cj. Capital Cj equal to Zj minus small cj. Zj is this value, small cj's are this value. So I am going to find out the capital Cj value. 0 minus 30, minus 30. 0 minus 20, minus 20. 0 minus 0, 0. 0 minus 0, 0. Does not want to calculate the Cj value for column B since it doesn't have a small Cj value. Okay. Now look at the Cj values. For an optimal solution, the Cj should be greater than or equal to 0. For an optimal solution. For an optimal solution, the Cj should be greater than or equal to 0. Look at here, there is negative values. We need to choose the lowest negative value. Otherwise, the highest number having negative sign. The highest number having negative sign is minus 30. If a number minus 2, minus 3, which is the lowest value? Minus 3 is the lowest value. Okay. If two negative numbers are given, the number which having the highest number which having negative sign is the lowest number. Among minus 30, minus 20, which is the most lowest value? Minus 30. So mark this column. This is known as the key column. This is the key column, which means now x1 will be coming to the basis. S1 will be coming to the basis. S1 will be coming to the basis. So if x1 coming to the basis, any one of these two basis variable should go out from the basis. Now we are going to find out which basis variable is going out. For that, we need to find out another set of value known as ratio. We are simply finding out ratio by B divided by key column. B value divided by our key column values, corresponding values. Look at here, 1500 divided by 3. Value is 500. That is 1500 divided by 3. Second, 1000 divided by 1. Value is 1000. 1000 divided by 1. Value is 1000. In this ratio, we need to choose the minimum positive ratio. That is 500. This is the key row. Key row, and the basic variable corresponding to the key row, that is S1. This is the outgoing variable. This is the outgoing variable and x1 is the incoming variable. So we are writing it here. need not write in the table, should be neat. We need to write here x1 is the incoming variable and s1 is the outgoing variable, and the element which include in the key column and key element, this is the key column and key row, this is the key row and this is the key column, which is the element that 3. This is known as the key element. This is known as key element. This 3 is known as the key element. In the next iteration, that is when we are going to prepare the simplex table 2, we need to make this key element as 1. We need to make this 3 as 1 by row transformation only, not column transformation. We can only apply row transformation here. We need to make this 3 as 1 and all other elements in this column, that is this one, we need to make this as 0. So in the next table we need to make 3 as 1 and 1 as 0 only using row transformation. Okay. Now we are going to make this 3 as 1 by dividing the row 1 by the number 3. If I am dividing the first row by 3, I can make this 3 as 1. Now in the next table, x1 should be in the basis and we need to change the basis. So basis will be x1 and s2. Similarly, all other column variables are there: x1, s2, s1, s2, b, cb and cj. cb value, now x1 having value in the objective function, that is 30. So here it should be 30, 0. cj values are 30, 20, 0, 0. Now we are going to convert the key element into 1 by dividing row 1 changes to row 1 divided by 3. Row 1 changes to row 1 divided by 3. I am going to divide row 1 with 3. 3 divided by 3, 1. 1 divided by 3, 1 by 3. 1 divided by 3, 1 by 3. 0 divided by 3, 0. 1500 divided by 3, 500. So our R1 become 1, 1 by 3, 1 by 3, 0 and 500. Now I make to, since x1 is a basic variable, its column should be of unit vector. If this value is having 1, all other elements in that column should be 0. So in order to make this value as 0, what should be done? What is the value here? 1. This 1 minus this one. Okay, so R2 changes to R2 minus R1. This R1 in the R2 in the simplex table 1, this R1 from table 2. So table 2 R2 is equal to, I need to make row transformation with table 1 R2 and table 2 R1. ഏതാണോ നമ്മുടെ കീ എലമെൻറ്റ് ആ റോ വെച്ച് വേണം ബാക്കി റോയെ നമുക്ക് ട്രാൻസ്ഫോർമേഷൻ ചെയ്ത് മാറ്റാൻ. അല്ല സിംപ്ലി ഇവിടെ R1 ഉണ്ടല്ലോ, ഹിയർ ദർ ഈസ് R1, സിംപ്ലി R1 minus 1 ചെയ്താൽ പോരെ എന്ന് പറയരുത്. ദാറ്റ്സ് നോട്ട് പോസിബിൾ. വി need to use key element row in this table. Using that, we need to convert all other elements in the key element as 0. So R2 changes, R2 is equal to this R2 minus this R1. Okay, so 1 minus 1, 0. Second, 1 minus 1 by 3, 2 by 3. 0 minus 1 by 3, minus 1 by 3. Next, 1 minus 0, 1. 1000 minus 500, 500. Now, in the same method in the table 1, I am going to find out Zj value. 30 into 1 plus 0 into 0, 30. 30 into 1 by 3, that is 10. Plus 0 into 2 by 3, 10. 30 into 1 by 3 plus 0 into minus 1 by 3, 10. 30 into 0 plus 0 into 0. 30 into 500 plus 0 into 500, that is 15,000. Now Cj equal to Zj minus Cj. 30 minus 30, 0. 10 minus 20 minus 10. 10 minus 0, 10. 0 minus 0, 0. Check at the value. Here there is a negative. For optimal solution, all Cj value should be greater than or equal to 0. Here it is, there is a negative value. So this is the key column. So x2 should be the next incoming variable. So I am going to find out the outgoing variable by looking at the ratios. So ratio here, b divided by, which is the key column, x2. b divided by x2. So 500 divided by 1 by 3, that is 1500. 500 divided by 2 by 3, 750. Which is the lowest positive ratio? This one. So this is the key row and this is the key column. Which is the key element? This 2 by 3 is the key element. So in the next table, which is the incoming variable? x2. x2 is the incoming variable and s2 is the outgoing variable. s2 is the outgoing variable. Now we are going to move for simplex table 2 since it is not optimal. Simplex table 3. We are going to simplex table 3 since the table 2 is not optimal, it having a negative value in the Cj. So which is the incoming variable? x1 is there instead of s2, which is the basic variable x2. So these are the bases: x1, x2, s1, s2, b. Then cb 30 and 20. Cj values 30, 20, 0, 0. Okay. Now I am going to make this 2 by 3 as 1. How can I make this 2 by 3 as 1? This is the row 2. So R2 changes to what type of row transformation should be done? You just simply multiply the reciprocal of key element with the row. It becomes 1, which is the reciprocal of 2 by 3, 3 by 2. So R2 changes to 3 by 2 R2 changes to 3 by 2 R2. 2 by 3 into 3 by 2, 1. Okay. So 0 into 3 by 2, 0 into 3 by 2, 0 into 3 by 2, 0. 2 by 3 into 3 by 2, 2 by 3 into 3 by 2, 1. Minus 1 by 3 into 3 by 2, minus 1 by 2. If you have any doubt, please write it here. Minus 1 by 3 into 3 by 2, 3 got cancelled, minus 1 by 2. Then 1 into 3 by 2, 3 by 2. Also for column B, 500 into 3 by 2, 750. 750. Now I need to convert R1 also in order to make this value as 0. Why? This is the key element. I make the key element as 1. So all other elements in that row, if it has a third row also, should also be 0. All other elements in that column should be 0. In order to make this value as 0, what should be done? This is the corresponding element here, 1 by 3. So R1 changes to R1 minus 1 by 3 R2. R1 changes to R1 minus 1 by 3 R2. This is also simple. Look at the value here. What is it? 1 by 3. Just multiply that value with our new row, that is R2. 1 by 3 R2. If it is a positive sign, subtract that from the existing R1. If it is a negative, add it to the existing R1. If it was minus 1 by 2, if it was minus 1 by 2, we need to multiply the new R1 with 1 by 2. Since it is minus, we need to add. If it is 1 by 3, we just multiply 1 by 3 with new R2 and subtract. If it is minus 1 by 3, we need to add. Okay. So R1 changes to R1 minus 1 by 3 R2. So values will be 0 minus 1 by this 0. Sorry, 1 minus 1 by 3 into 1 minus 1 by 3 into 0, that is 1. Next, 1 by 3 minus 1 by 3 into 1, that is 0. Next, 1 by 3, this is 1 by 3. 1 by 3 minus 1 by 3 into minus 1 by 2. If you have doubt, please write here 1 by 3 minus 1 by 3 into minus 1 by 2. Okay, so it become 1 by 3 plus 1 by 6. So find the LCM and solve. It will become 1 by 2. Since LCM is 6, 3 by 6, that is 1 by 2. 1 by 2. Here also 0 minus 1 by 3 into 3 by 2. So value will be minus 1 by 2. In column B, 500 minus 1 by 3 into 750. So answer is 250. Here it is 500 minus 1 by 3 into 750. This 500 minus 250. 250. Okay, now we are going to find out the ZJ values. 30 into 1 plus 20 into 0, 30. 30 into 0 plus 20 into 1, 20. 30 into 1 by 2 plus 20 into minus 1 by 2, answer is 5. 30 into minus 1 by 2 plus 20 into 3 by 2, answer is 50. 30 into 250 plus 20 into 750, answer is 22,500. Then Cj equal to Zj minus Cj. 30 minus 30, 0. 20 minus 20, 0. 5 minus 0, 5. 15 minus 0, 50. So all Cj values are greater than or equal to 0. Sin all Cj greater than or equal to 0, solution is optimal. And the optimal solution is x1 is equal to, what is the value in the B column? 250. x1 equal to 250. x2 equal to, value of x2, 750. And maximum Z is equal to this value, 22,500. Otherwise you can substitute these 250. Otherwise you can substitute these 250 and 750 in the objective function, that is 30x1 plus 20x2 plus 0s1 plus 0s2. If you are substituting x1 equal to 250 and x2 equal to 750 in the objective function, we can get 22,500. So x1 is equal to 250, x2 equal to 750, and Z max is equal to 22,500. This is the optimal solution. I hope all of you understand this. Thank you.